Okay, so now what I've done is instead of 1 meg down from the gate to 0 and 1 meg up from the gate to plus 5 volts, I have a little jumper wire over here, and I have two 1 mega ohm resistors in parallel going up to 5 volts. So that should bias the gate. Instead of biasing the gate to 2.5 volts, that should bias the gate to 2/3 of 5 volts, which is 10/3. I guess that's like about 3.33 volts. So now we look at the waveforms and you see the clipping is a little less severe. And I think actually if I just go to waveform generator and reduce the amplitude from 2 volts to 1 volt, and then go back over to scope. Oh, that's not quite good enough. Well, here, let's see. What if I reduce the amplitude to 1/2 of a volt? And then I go over to scope. Aha, so that's not too bad. Now the clipping, let me change the trigger threshold. So trigger level will make, I think I can just type in a number. We're gonna make the trigger level be 3 volts. Okay. So that's not too bad. I'm a little confused actually that the average still seems to be 2.5 instead of 3.3. Oh, let me go take a look. Select channel 1. Yeah, that's a little confusing. Okay, we won't worry about that for now though. So you see clipping's a little less severe maybe, but there's still about a 2.5 volt. So you see instead of a diode drop of 0.6 volts, instead we have a little bit more than V threshold. And V threshold for this N-channel enhancement mode MOSFET is about 2.5 volts. Let's turn the amplitude of the waveform down even a little bit more. I think I can type in an arbitrary number. Let me make it 250 millivolts. So now it's 500 millivolts peak to peak. And I'll go over to scope. Oh, I have to adjust Mr. Oh, look at that. I can just drag the trigger threshold. Okay. So now you see that the source is in fact following the gate, but actually with a slightly reduced amplitude. I guess we didn't offer you any explanation for the reduced amplitude, but still you can see that at least sort of qualitatively, I'm going to try to tinker with the offset so that I can get the two waveforms to overlap somewhat. Oh, okay, so let's do 500 millivolts. Maybe 400. Yeah. So maybe I should try to come up with an explanation for the reduced amplitude, but it's not really that important for our purposes. We want to see that we can get qualitatively the same kinds of circuits with an N-channel MOSFET as we got with an NPN transistor. And I think if we really carefully handle the so-called transconductance, the equivalent of little re, actually the reciprocal of little re is called G, little g sub m for a MOSFET, then I think we could understand quantitatively why the output amplitude is a little bit smaller than the input amplitude. But again, the main idea is we can see the output follows the input. In other words, the source follows the gate, but with a shift which is a little bit more than V threshold. In this case, V threshold is about 2.5 volts. Okay, So that's not too bad.